Good morning. So today our next lesson in chapter 7 is on arithmetic sequences and series. So yesterday we just kind of went over sequences and series in general, talked about sort of the differences, what they are, and we explored writing the rules for a few different sequences, but the types of sequences that we had, some were arithmetic, which meant the pattern was increasing or decreasing by the same number repeatedly, like maybe it was going up by 2s or down by 3s or something like that. We also looked at some patterns where the numbers were, increasing by maybe 2, then 4, then 6, or they were being multiplied by something, and all sorts of different types of patterns. But today we're just going to focus on arithmetic sequences and series. And we're going to go over how to determine what's arithmetic, what's not, which we did touch on a little bit in yesterday's lesson. And then we're going to use some formulas that can be used specifically for arithmetic sequences and also arithmetic series. So the first thing is, as we kind of mentioned yesterday, an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. So we kind of almost referred to it like a slope a little bit yesterday, because it's going to make a rule that's sort of similar to a linear equation. And the constant difference is called the common difference. So basically what happens is, if you take a look at these patterns here, this first pattern, to get from -3 to 1, you'd have to add 4. And then to go from 1 to 5, you'd have to add 4. And to go from 5 to 9, you'd have to add 4, and so on. So we can see that this would be an arithmetic sequence, because it increases by the same number, as you go through the sequence from term to term. So yesterday when we were writing a rule about this, so this one is arithmetic. So if you just think about arithmetic, it's like the math you learn in like first grade, and it's just adding and subtracting pretty much. And when we do write a rule for something like this, and we did explore that a little bit yesterday, even though the directions aren't asking us to do this right now, we knew that we were going to start somewhat with that 4n, and then maybe we'd be adding or subtracting something to it as well. So if this were an input and I multiplied it by 4, I would then have to subtract 7 to get that output. But I'm getting a little ahead of us. Right now we're just determining what's arithmetic and what's not. So if we look at number 2, to get from -10 to -6, we would add 4. To get from -6 to -2, we would add 4. But then to get from -2 to 0, you're only adding 2 for the next 2 steps, and then you're going back to adding 4. So this would not be arithmetic. Okay, so this one, this particular sequence, it may or may not have a rule to it. It's definitely not going to be arithmetic, so we're not going to write a rule similar to what we were working with before. So in number 1, since it was arithmetic, this +4 is known as that common difference. So we would say that the D equals 4. So the nth term of an arithmetic sequence with the first term called a sub 1 and the common difference D is given by the following formula. Now, this particular formula, you have the a sub n, and it's written as a sub 1 plus n minus 1 times d. Now, for whatever reason, we're so used to distributing things from the left, so a lot of times I like to just kind of rewrite this, and I'll do, d times n minus 1 plus a sub 1, and I'll write it that way. It's the same thing. It doesn't matter. I'm just kind of making it a little bit easier to work with. So whether you want to use it this way, or you want to use it the way it's already written down, it's the same thing. So basically what's going to happen is you're going to take that common difference, you'd multiply that to the n that you're looking for minus 1, and then you'd add that first term, whatever it is. So we're going to use that formula to write the rules for this next section here, and then we're going to use it to find a sub 10. So a sub 1 is basically just what's the first number in your sequence. So if we're looking at this first sequence here, 32 is a sub 1. Now the pattern is that common difference. So what is going on from one number to the next, or what are we adding or subtracting if these are arithmetic sequences? So from 32 to 47, we're going to add 15. To get from 47 to 62, we're going to add 15 again. And then to get from 62 to 77, we're going to add 15. So we can see that there's a constant change there of adding 15 to each number to get the next number in the sequence. So we know that it's an arithmetic sequence, and the common difference is positive 15. The first number in the sequence was 32, so that's how we know that the a sub 1 is 32. So now we can just plug it into the formula. So our a sub n equals, now if we write it the original way, a sub 1 is 32 plus, and then this is just going to be n minus 1, that variable stays n, and you're going to multiply that by your 15. So really what's happening here is, since I can't do n minus 1, you're distributing that 15 to each of those, which is why I like to kind of write it in the other order. So now we have 32 plus 15n minus 15. These two here are like terms, so I end up with 15n plus 17. And this is called an explicit rule. An explicit rule, all the rules that we're going to write using these formulas today and tomorrow for arithmetic and geometric sequences are known as explicit rules. And that's just because you basically just plug a number in. It's like an input-output type situation. You plug a number in, and you get a number coming out. So you plug in 1, get the first number of the sequence. You'd plug in 2, get the second number, and so on. Next week, we're going to go over something called recursive rules, and those are a little bit different. But anything we work on this week are all explicit rules. So if you see that in the quizzes for homework or something, don't get confused. Explicit is just these input-output type of functions or rules. So now for the next problem, finishing that up, it says then find a sub 10. So once you have the rule, it's kind of like having a little formula. You can plug anything in and solve it at that point. So if I want to know the 10th number in the sequence, because right now I only have the first 4 numbers in the sequence, and I don't feel like adding 15 6 more times. So all I have to do on my calculator is 15 times 10 plus 17. And then I can solve, and I know that the 10th number in my sequence is 167. Okay, so now let's take a look at number 2. So number 2, we have the first 4 terms here. We can see that our first term is 50, so that's going to be our a sub 1. And then we want to look at the pattern here, what was happening as we go from one number in the sequence to the next. So to get from 50 to 44, we would subtract 6. To get from 44 to 38, we would subtract 6. To get from 38 to 32, we would subtract 6. So that tells me that my common difference is a negative 6. So now using the formulas there up at the top, and this time I'm going to do it this way. It's the same formula, it's just rearranged a little bit. So if I put in my d value, which is negative 6, and I multiply that by n minus 1, and then I'm going to add my first term, which was 50. So I'm going to distribute my negative 6 here. So I get negative 6n plus 6 plus 50. And then those two like terms get combined, and I have negative 6n plus 56. So a sub n equals negative 6n plus 56. That would be my explicit rule for this arithmetic sequence. Now, if I want to use that rule now to find my a sub 10, I'm just going to plug in a 10 for the n. So I end up with negative 60 plus 56. So a sub 10 would equal negative 4. And that's it. Okay, so now in the next section, we're going to write the rule. And this time, instead of them giving us the sequence, they're giving us the common difference, and they're giving us one of the numbers in the sequence. So there's a couple ways we can go about finding that a sub 1. So, one way, if you know that the 8th number in the pattern is 50, let's say, right? So this is one option. It's kind of the longer option, but I'm just going to explain it anyway. So we know that the 8th term in the sequence is 50. And we know the common difference is 3. So we know that every number here, if you add 3 on it, you get the next number. So if we go backwards, 15 minus 3 would be 47. Minus 3 would be 44. Minus 3 would be 41, 38, 35, 32, and 29. So that's one way to get the a sub 1. Now this one wasn't so bad because they gave us the 8th number and it was an easy number to subtract each time. But if they gave you like, I don't know, the 100th number or something like that, might be a little bit more of a pain to do it that way. So instead, we can just plug into the formula that was up at the top. So I'm just going to scroll up real quick so we can take a peek and then I'll copy it down. So if we have a sub n equals, and we have a sub 1 plus n minus 1 times the d, right? So they're giving us basically an n value. This 8 is our n, and then the a sub n is the 50. So they're telling us the 8th term is 50. So we can plug those in to then find the a sub 1. So if I plug that in, I would have 50 equals a sub 1 plus 8 minus 1 times 3. Now here you're just using your PEMDAS. 8 minus 1 is 7. 7 times 3 is 21. And then we would subtract the 21. And you have a sub 1 equals 29, which is the same thing we did by setting up the sequence and just counting backwards and filling in the blanks. So it doesn't matter how you get it. There's, a few different options of what you could do. Now, the trick is, once you get it, we now want to write our rule, which is the whole point of what we were trying to do, right? Write the rule here. So if I'm going to write my rule, my a sub 1 is 29 plus n minus 1 times d, which we know the d is 3. So I have 29 plus 3n minus 3. I combine my like terms. So 3n plus 26 is my explicit rule. Okay, so in order to use that formula to write the explicit rule, you need to have the common difference, where the d, and you also need to have that first term, where the a sub 1. If they're not giving you both of those, you need to find whatever you're missing and then write the equation or the rule. Okay, so number 2, as you can see, they're giving me the 15th number in the sequence as 36, and then I'm going to have to the common difference was you were adding a half each time. So I could, subtract a half 15 times and figure out what number that is, or I can just go ahead and use the formula here. And I know that the n is going to be the 15, and the a sub n that they're giving me is 36. So I'm going to just plug that into the formula real quick just to find my a sub 1. So I'll have 36 equals a sub 1 plus 15 minus 1 times 1/2. Well, 15 minus 1 is 14, and half of that is 7. And then if I subtract that, I get a sub 1 is 29. It's just random that it ended up to be 29 again. That's not usually the a sub 1. And now that we have an a sub 1 and a d, I'm going to use those two to write the actual rule, the explicit rule. So a sub 1 is 29 plus n minus 1 times 1/2. So I get 29 plus 1/2 n minus 1/2. Combining those like terms there. 29 minus 1/2 is 28.5. So that would be my explicit rule for that sequence. Okay, so now an arithmetic series, if you remember from yesterday when we refer to a series, it's really like the sum. So if we took all the numbers in our sequence and we added them up, what would we get? So when you're doing an arithmetic series, there's a formula you can use because all arithmetic series, each row or each term is adding or subtracting a specific amount. So since we know like whatever that pattern is, we can then kind of figure out using this formula what the total would be for however many number of terms or like rows or levels or whatever it is that you're talking about. So the expression formed by adding the terms of an arithmetic sequence. So it's finding the sum. That's why we use this S sub n, because we're referring to the sum. Whenever we have a series, it just means it's all the numbers being added together. So you would need a few pieces of information. You need to have your a sub 1, which is the first term. That does not change. That's going to be the same for the sequence. So whatever sum you want to find, let's say you want to add up the first 10 terms of the sequence, or you want to add up the first 20 terms of the sequence, or the first 900 terms, your a sub 1 is going to be the same no matter what. That's not going to change for the sequence that you're dealing with. The n and the a sub n, however, it's going to depend on how many things you want to add up. So if I'm just going to add up the first 7 terms of the sequence, then my n would be 7. And my a sub n would be, well, whatever that 7th number is in my sequence. If I wanted to do the first 100 terms, then n would be 100, because that's how many numbers I'm going to add up. I'm going to go up to the 100th term in the sequence, and then whatever that 100th term is would be your a sub n. So you need to have all 3 of those. The first one's not going to change, but the second 2 are going to be variable depending on what your directions are. So find the sum of the first n terms of the arithmetic sequence. So if you're doing this first one here, right, they're giving you the n, and obviously they're giving you the a sub 1, because that's the first term in the sequence. Now, at this point, you need to find the a sub n. So like, what is that 10th term in this case, right? So we have the first 4 now. A couple ways you can do this. If you see that the pattern is adding by 3 each time, you could just kind of continue the pattern until you get to the 10th term. So that would be one option. So we got 4, 7, 10, 13. You might say, okay, 16, 19, 22, 25, 28, and I think we have to go to 31, right? 4, 5, 6, 7, 8, 9, 10, right? 31. So a sub n is 31. So you can get it that way. Another option is you would have to get the rule. So we know that the d here was adding 3. So if you just do the formula we did on the last page, your a sub 1 is 4 plus n minus 1, so that would be 10 minus 1 times the d, and you can easily see the d from the pattern is being multiplied by 3. So then you just work that out to find your a sub n. 10 minus 1 is 9, 9 times 3 is 27, 27 plus 4 is 31. So you can use the formula from the last page to find it. You could finish up the sequence and find it that way, whatever way works for you. So now we're going to fill in the sum formula. So the n is 10, and then we're going to do a1, or that first term, which is 4, plus the 10th term, which we figured out was 31, divided by 2. So essentially what you're going to do is, when you're finding out the sum, you're taking the first term and the last term and you're averaging them together. So we knew the first term was 4. We figured out the last term was 31, and we're adding them up and dividing by 2, which is basically just averaging them together. So that's 35 over 2, which I think is 17.5. So once you average those 2 terms together, you're just multiplying it by the number of terms that you were adding up. So in this case, it was 10. So 17.5 times 10 is going to be 175. So the sum of that series, the first 10 terms of it, would be 175. Okay, so now when we take a look at the next one, again, I could figure out what my 25th term is, but I only have 4 numbers here and I don't feel like doing 19 more. So I'm just going to use the formula this time. Now I know my n is 25. The d, if I look at my pattern, it's decreasing by 2 each time, which means my d is negative 2. And of course, my a sub 1 is that first term, which is 20. So to find my a sub n, I'm going to do 20 plus n minus 1, which in this case would be 25 minus 1, times that d, which is negative 2. Now be careful because you're distributing that negative, so it's going to become minus 25, and then, actually you can do it that way, it should still work, but 25 minus 1, just use PEMDAS easier. 24 times negative 2, negative 48, and then that's going to be negative 28. So my a sub n is negative 28. So now I can put it all into the sum formula. So 25 is my n that goes on the outside. And then I have to average up my a sub 1, which is 20, with my last term, which is the negative 28 that we just calculated. So that's going to give me negative 8 divided by 2, which is negative 4. And then when I multiply that together, I get negative 100. All right, so now we're going to do the same thing on numbers 1 and 2. In the bottom, the information is just given to us in the sigma notation. So if you remember from yesterday, this is basically telling us we're going to go from the first term to the 15th term. So that would mean that my n is going to be 15, because we want to figure out the sum of the 15 numbers in the sequence from starting with the first going to the 15th. Now the a sub 1 is the first number in the sequence. So if you just plug a 1 in here, right, for that I, 3 times 1 is 3, 3 plus 2 is 5, we would know our a sub 1 is 5. And if we want to know our a sub n, in this case, it's going to be a sub 15, right, because we're going up to 15. You just do 3 times 15, which is 45, plus 2 is 47. So I actually think it's a little bit easier when they give it to us in this notation. And then we're using the same formula at the top of our page. So the n was 15, and then we're going to average together the first term, which is what we got when we plugged in the 1. So that was 5. And then the a sub n, which is what we got when we substituted the 15 in, which is 47. 5 plus 47 is 52. 52 divided by 2 is 26. And when you multiply 15 times 26, you get 390. Like that. All right, and then let's do our other one here. So again, we have our n value is going to be 30 because we're going from 1 to 30. So we want to add up the first 30 terms. The a sub 1 will be what we get when we substitute a 1 in here. So 6 times 1 minus 1 is 5. And then the a sub n in this case will be a sub 30. So what do we get when we substitute the 30 in there? 6 times 30 minus 1 is 179. And then we can put them in the formula. So we have the 30, and then we're going to average together the 5 and the 179. So we add those up and divide by 2, and we end up with 92 point. Wait, messed something up. We end up with 92. And then 30 times 92 would give us a sum of 2,760. Okay. And that's basically it for today. So as you can see, our arithmetic sequences and series are a little bit more straightforward than yesterday. Yesterday was a little bit of guessing and checking on some of those rules. So for this case, if you know it's a sequence that's arithmetic, meaning that it increases or decreases by the same number repeatedly, you can use these formulas to find either the explicit rule for the sequence or the series, or the sum of that series. All right, and that's it for today. Make sure you let me know if you have any questions, and you will have a homework assignment to complete on the quizzes. Thanks for checking in. Have a great day.